Okay, let us see now. This one is also combining a hinge and then a ladder or a rod. So if we don't see a rod, it means that we are talking about ladders. Okay, a uniform beam, a beam is also the same as a rod, or you can say ladder, no problem. Of mass 8 kilograms and the length 8 meters is hinged at A. A hinge. By the people were asking, what's a hinge? A hinge is like a pattern. If you look at the door, if this is a door and this is a wall, there is that thing that allows the door to move clockwise and then anti-clockwise. That's what we call a hinge, or in simple terms, the pattern, simply known as that. Okay, so it's between the door, it's at the door and then at the wall, or that vertical distance. I mean that vertical wooden wall, or if it's metallic, so that thing there that allows the door to move to and flow is what we call a hinge. Okay, at A and is maintained in the equilibrium by two strings attached to its points C and D as shown below. As you can see, this is 4 meters, this is AD, this is SC. The tension is this, the tension in BC, the tension in BC, this is in BC, is twice the tension in BD. AB is that and AD is that. So find the tension in the string BC. So we need to get first of all our AD. So that our AD is 3 over 4 SC. This will be 3 over 4, but our SC, the length of our rod SC is 8. So see this one, our AD, right, is going to be 6 meters. So AD, first of all, is 6 meters. So if from here up to here is 8, it means that from here up to here, and this is 6, so it means this is going to be 2 meters. That's how we digest the equation that it is. Then we come to this. The tension in BC is twice the tension in BD. So if you know the tension in BD as it said T, this tension is T, then this one in the BD is going to be 2 times. So this is 2T. As simple as that. Now, we don't know this angle, we don't know this angle. Let me call this one theta, and let me call this one alpha. You can call it your own. That one doesn't take a lot of energy. Now, it means that now, to get the tension now, you know this is a hinge, it means that we expect a reaction. Our reaction is going to be in this direction, R. So, the easiest way is to resolve this vertically. So it shall be having the horizontal component, I mean the vertical component, and then the vertical, and then the horizontal component Rx. Now, they ask you to get a tension in the string, we always get moments at the hinge. Why? Because the hinge has many forces, as I'm going to show you. Now, if you resolve this one here, if I try to resolve this P2, I'm going to be having this case here. Be careful, and then I'm going to be having this here. So, this one, I'm resolving this. This is adjacent, so this is going to be 2t cos alpha. This one is going to be 2t. The vertical distance is going to be opposite to this, sine alpha. Then if I try to resolve this, I'm going to be adding, this one is going to be our vertical component, and this is going to be our horizontal component. So this one, you see it's adjacent, so this one is going to be t cos theta. This one is going to be t sine theta, the vertical component. But in these diagrams, we put it from the point where it starts. Because when you put here, you get confused when you are getting the momentum. I mean the moment. Sorry, the moment. So that's how we resolve them. Now, you see at the hinge, there are many forces. There is this. You see this one is coming at the hinge, even this one is coming at the hinge. So meaning, we take moments where we have many forces. So, to get this tension in the string now, means that I'm going to take moments at A. So taking moments at A. Why? Because at A, there are many forces. So, if you take moments where there are many forces, all those forces, their moments are going to be zeros because they will be having no perpendicular distance. So, they don't have the perpendicular distance, it will be 0. Okay, so resolving anticlockwise, you see this one is going anticlockwise, and also this one is going anticlockwise. So, this is going to be, its moment is going to be 0, even this is going to be 0, even this is it's coming to A is going to be 0, even this one is coming to A. So all those which are coming to A or going from A, all their moments are going to be 0. So surviving things we are going to be having now. Remember this rod of ours was of mass 8 gig. So it means that it was having a weight, a given weight. So let us put our weight here. Let me assume this is going to be the middle. I don't know. Let me put here. I'm going to be having my weight there as 8 gig. So it means that from here up to, so it means that from here up to here is going to be 4 meters. Because this is 6, and from here up to here it's going to be 2 meters from here up to here. So that we have the 6. Then from here up to here, the 6 is going to be 4. Anyway, so we take moments at A. Take moments at A. This one is going to be surviving. This is going to survive, this is going to survive, and this is going to survive. So only 3 forces are the ones which are surviving. This, because they are not from A, or they are not coming to A. So, anti-clockwise, we are going to be having this and this. So we have, first of all, T sine theta times its perpendicular distance from A. Perpendicular distance from A, from here up to here. This we have from here up to here was 6. AD is 6. So times 6. Then plus 2T sine alpha. The perpendicular distance from here up to here is the distance of the rod, which is going to be 8, equaling to, this one is the only one which is going clockwise, using principle, I think we see clockwise. So we're going to be having 8 then times the distance from here up to here, which is 4. From here up to here is 4 meters, because this is the weight and this is the uniform, so the weight will be acting in the middle. Okay, now our question is, how do we get alpha there? Okay, you see, from here up to here, okay, let me use this diagram so that you can able see it from here. So if I have this as my theta, remember from here, this is D, this is A, this is B. So AD is 6 meters, this one is 4 meters, it means that I can get this as the square of this plus the square of this. This is 36, this is 36 plus 16, that will give us 52, then the square root of 52. Okay, when I come now to the other one, which is alpha, I will be having A, C, B. This is 4 meters, SC is 8 meters, then we shall get this squared plus 64 squared, which will give us 8, then we get the square root of 80. So now I have that. So it means that now from here, I can get tan T. So that my T is common, so if I factorize out T, I'll be with the sine theta. Okay, 6, okay, times 6. Then plus, this time this I have 16 sine alpha equaling to 24 times, okay, not 24, that is the 32. Okay, so I have 4 times 8, 32D. So from here, it's that our T into now, what is our sine theta? We have 6, then times sine theta. I think you see from here, it's opposite over hypotenuse. So we have 4 over root 52, then plus 16 times, this 2 was factorized out, sine alpha, you see it's going to be the opposite over the hypotenuse, which is 4 over root 80. They're all equaling 32 times 9.8. And from there, strictly get the T. Okay, let me get the T there. That's my answer there. I think you can see. So you have here 27.0565 newtons. So that's going to be my tension. It means that's going to be my tension there. Then after getting the tension, after getting the tension, this is now the tension in this tension in BD. So one the tension in BC. But our BC is going to be 2T, which would be 2 times 27.0565. So our BC, our 2T, this is not equal the tension in BC will be equal to 2 times 55, which is going to be 54.113 newtons. That's our tension in the string BC. So that's part A. Then we come to part B. Okay, this one is my A. Then I come to part B. You want me to get the magnitude and the direction of the reaction and the hinge. Remember here, reaction and the hinge. You take horizontal, you dissolve horizontally. You take horizontal you take horizontal components and then the vertical component. As simple as that. So, but horizontally, dissolving horizontally, have Rx. You see RXC is the only one going in this direction. Then we have these two opposing. We have T, so it's going to be equal to T cos theta plus 2T cos alpha. So if we put them there, it's going to be our T there, 27, so it's common, okay, which is the same as T into cos theta plus 2 cos alpha. So 27.0565 into cos theta. From here, cos theta is adjacent over hypotenuse. Adjacent over hypotenuse. Then plus 2 times cos alpha adjacent over hypotenuse root 8. Then your Rx here is going to be, okay, it's going to be, so that's my answer for Rx there. So here we're having 70.9125 newtons. So after that's done, we resolve vertically so that we can get, you see vertically we are going to get this Ry, the vertical component. So vertically we have this, we have this, then plus T sin theta plus 2T sin alpha is going to be equaling that those acting downwards. We have only 8E. So impedance our Ry is going to be equaling to 8E minus, when I take this side, see it is common here, sin alpha, and then theta plus 2 sin alpha. So my Ry is going to be 8 times 9.8 minus 27.0565 into sin alpha, sin theta, which is equal to opposite over hypotenuse, then plus 2 times sin alpha, which is the opposite over root 8. And so from there, my Ry is going to be, okay, before that, members, this, I think I mispressed the calculator, so let me correct this, and also correct this, then I also correct this, then if I get to that. Okay, that's the answer I'm getting on Ry. So please, this one we had crossed, this one, change to this. This was our T, then the rest changing. This was, the value was not pressed well. So 5.0518 newtons, as simple as that. Now, these ones, now they are going to give us the reaction. So, you see that our reaction is there. It's given by this R, Y, and then this is our R, X. This is going to be our reaction we are looking for. So that our R is going to be root of Rx squared plus R squared Y. So our R will be the square root of 35.0518 squared, then plus 78.3991. So from there, my R is going to be root. Sorry. It's going to be 85.8788 newtons. So our direction, so let us call this theta. So the direction, this is our theta. So our theta, where it is going to be tan inverse of, this is going to be the opposite, which is Rx. 78.399 over this is going to be our opposite, which is going to be there, then the adjacent, which is that 5.0518. So the direction, this is going to be the direction, 78 point. So this is 65.91 degrees. So that's the reaction at hinge, and this is going to be our direction. So that's how we handle that. I wish you well.